Mr. Samir, please don't share his presentation, any screen.
रजिस्ट्रेशन कर लो।
Dear participants, I request you to mute your mic and turn off your webcam, and also do not share any presentation, any screen in between while presentation is going on. Thank you. Madam, shall we start? Okay. Dear participant, we will start the session within few minutes. So I request once again to all the participants, turn off your cameras and mute your mic, and as well as please not to share anything in between while the presentation is going on. Thank you.
Ma'am, hello madam. Unmute madam. So, audio unmute madam.
Yes, sir.
Oh.
Sir.
Start, ma'am.
Yes, sir. Sure, sir.
Good afternoon, one and all. I, Professor Shilpa Hosgaudar, feel privileged to welcome you all to the webinar on recent trends in computer science and technology organized by Department of Computer Science and Engineering, KLECET, Chikodi. In spite of unfavorable situation created by COVID-19, Department of CSE is very keen to produce the awareness about teaching and learning, and this event is an example. Before we start the event, let me introduce about KLECET Chikodi. KLE's success story of nearly 10 decades speaks volumes of the dedication and commitment of thousands of people that has created remarkable prints in India's educational spectrum. With 265 institutions spread across Karnataka, Maharashtra, Goa, and Dubai, each narrating their own amazing stories of enriching people's lives, a harmony exists that is very palpable. Our alumni settled in different parts of the world are a testimony to our achievements and are ambassadors in promoting the brand KLE throughout the world. The KLE Society's KLE College of Engineering and Technology is established in the year 2008 with the sole objective of imparting quality technical education for rural youth. The college is located in Taluka headquarters of Chikodi of Belgaum district. About 70 km from Belgaum, the campus has sprawling area of 16 acres at the foot of hillocks on the outskirts of the city. The city of Chikodi has a strong educational base and enjoys salubrious climate throughout the year. The institute is a self-financed, non-minority college recognized by AICTE, New Delhi and Government of Karnataka. It is affiliated to Visvesvaraya Technological University, Belgaum. The institute has state-of-the-art infrastructure and most modern facilities. College is doing very well under the leadership of our beloved principal, Dr. Prasad Rampure, who is source of inspiration behind all the remarkable achievements of KLECET Chikodi. Let me briefly introduce CSE department. The department was established in the year 2008-9 with an intake of 60. In the year 2014, the intake was increased to 120. During the placement drives held in the academic year 1920, more than 100 students have been placed in various reputed companies like TCS, Infosys, Global Edge, Entity Data, Wipro, Creator, Sankey Solutions. This year, our department got 5 projects selected for KSCST, Bengaluru, and 2 projects got selected for McAfee FAER. The department has 1 equipped laboratories with all the facilities needed for the VTU curriculum that meets the global standards. I also take this opportunity to welcome Speaker of the session, Dr. Nandini Sidnar, HOD for the Master's Program at Melbourne Institute of Technology, Sydney Campus, Australia, who will be presenting on the topic Blockchain for Securing Medical Document. It is my proud privilege to introduce Dr. Nandini Sidnar Madam. Nandini Madam has completed her BA from GIT Belgaum, MTech from MSRIT Bengaluru, and PhD from VTU Belgaum. Madam started her teaching career in KLE's MS Sheshagiri College of Engineering and Technology Belgaum, spanning over 20 plus years. Madam worked as a special officer and also as a PG coordinator for 5 years VTU Belgaum. Madam is currently HOD for the Master's Program at Melbourne Institute of Technology, Sydney campus, Australia. Nandini Madam has held a number of academic positions like Academic Manager, Head of the Department at universities and educational institutes both in Australia and overseas. Madam research interests lie in the area of cognitive computing using intelligent agents, data analytics and semantic web. She has more than 30 research publications in peer-reviewed journals and has presented some of them in international conferences. She has published a couple of books on cognitive computing for bidding in e-auctions, Scholars Press, and a C programming laboratory handbook for beginners by Wiley Publications. Madam had developed intelligent multi-agent framework for adaptive e-learning as a part of master thesis work. Further, Madam was a lead member to implemented virtual learning assessment for specific master courses of VTU in 2005. Now, an active member of sponsored project at MIT on game-based learning and is practicing feed-forward learning for industrial project-based units. With this brief introduction, I present before you Dr. Nandini Sidnar Madam. Thank you one and all. Now over to Nandini Madam.
Thank you, ma'am. I'll just present my desktop. I hope you are able to see my desktop. Are you able to see my desktop, please?
No, ma'am.
No, okay. I just presented one second.
Ravi Kumar, don't present your presentation, your screen. Mr. Ravi Kumar.
Yeah, I just present now. One second.
Yes, ma'am. Now it's visible.
Yes. I would like to thank all of you, the Chikodi team, for such a wonderful organization even during this COVID. It's really privileged, and the students are really lucky enough to see that they still learn the recent trends, whatever is happening, even amongst the COVID situation. It's really good on you. I congratulate the CS department, and more so Prasad Rampure sir for taking this initiative. However, this is our first beginning. Let's get associated and work together. At the very outset, I would like to thank and my best regards to Professor Anami, who is there. He's my teacher and a mentor forever. I would like to thank him for all the guidance that he has provided so far, and my beloved colleagues from Belgaum KLE as well. Okay, to begin with, I would like to just provide an introduction to blockchain. It's just an introduction because I want the students to develop their self-learning. I want them to get initiated from here and further explore in this area. Today, I'm just giving you an overview of what a blockchain is and how we could be using it to secure the electronic documents. Okay, before we start with what a blockchain is, I would like to ask the audience here, how would you verify that anything you do or anything you buy is original, it's not fake, or it is legitimate? Okay, if it is a currency, we verify it from a centralized authority, that's a bank. Check its number whether it's fake or legitimate. Be it a driving license, we go to our RTO office to verify whether it's fake or legitimate. Be it a real estate, we go to the registration center and check. So all of these authorities who validate the documents or the information at the moment are all centralized. Okay, the whole power is centralized. It all depends on the history that is registered. But is there a scope to change our history? Yes, of course. Many a times the history is overwritten. It has changed easily. It's just because most of the things are centralized. The authority is centralized. And from here, this leads to the financial crisis. So we get to know that a financial crisis has happened only after it is done. The centralization of information is a main crux over here. So we need to come up with a distributed application so that each and every person knows it and transparently maintains it. So blockchain is one such technology that will help us to distribute the application. It's just not a network as such, it's a technology which can be implemented in many ways, maybe in public or private and so on. But simply it is a distributed ledger technologies that can be programmed to record and track anything of value. Say for instance, it could be the land titles, it could be financial transactions, it could be medical records. All of these, it is really good to see that blockchain, if applied to all of these, it will be useful because it stores and tracks the data. It stores in the form of blocks, organizes all the information in a proper chronological order, maybe with respect to time. Any change in the content in any of the block will be notified to all those who are sharing it. Thus, we say that it becomes a non-destructive way to track data changes over a period of time. If you all remember about the Britannica books, that was the authority earlier. Whatever was written there was the Veda for us. We never questioned it, nor we were able to add any value to it, though we knew better than that. But later on, with the advent of internet and with Wikipedia, the information started decentralizing. In other words, more than decentralizing, I would like to use the term distributed. There's a difference between decentralized and distributed. So it's better we use the term distributed. And this began after the crisis. In 2009, loss of money was lost, and after that came up the blockchain. Blockchain, as I see, it's in essence a distributed database system, which means that we are trying to share all the information among the people who are involved in the network. Thus, instead of storing files on a single computer, we would be sharing it all across the network. For instance, if you consider your Facebook, when we log in, all the content that we have or our friends share on the Facebook, on any wall it could be, it's all stored on the central farm of servers. Facebook technically owns all our data. They use that for any targeted purposes. Okay? In this or in such a situation, blockchain technology disrupts this and gives end users the power to control their own identifiable information. In other words, blockchain is a disruptive technology. Now, before we go in, I would like you to just revise on the subjects that we have learnt in computer science. A review of data structure, the way the data is structured in the memory. We have learned, say, maybe stacks, queues, and so on. If we go a bit further, we have learned the concept of linked list. Further to that, we have also seen doubly linked list. I believe all of you have studied it in your computer science, the doubly linked list. This can be an analogy to the blockchain that I am talking today. Apart from that, the distributed computing system. And with that, I could say that centralized system is nothing but a central server and rest all our clients. That's a client server technology wherein the server was providing all the requests or serving all the requests of the client. But what if it goes down? Then the whole system fails. With that advent, what happened was we went on with the decentralized computing. In case of decentralized computing, the computation is spread out on multi-servers, or I can say it's a network of centralized servers. Not still very efficient, but better than centralized. However, this was not sufficient because the transparency was not much. So we went in for distributed computing. The best example for that is Netflix. Why do you think whenever you download a movie on Netflix, downloads very quickly? Why? It's because suppose if 5 of us are downloading a single movie, okay, who are geographically close by, then in that case we all are going to share whatever we have downloaded. In other words, I'm not going to download the entire movie on myself nor my 4 other friends. What happens is we download part of it and then we share amongst ourselves. And this sharing, wherein I become a client once and then a server once, is the best option that we have, and that's the distributed computation now. Or even the voting app, it's a decentralized application. We can still develop that so that everyone can view the votes, but nobody can modify it. However, if in case somebody would like to tamper it, then the person who wants to tamper has to first work out with the hash. Now, the next question comes, what is a hash? I believe right from your DBMS subject, you have been learning about hash. Hash is nothing but it's a number or an alphanumeric that is generated based on the text given to it. This hash is not an encryption or a decryption key. It's irreversible. Where do we use this hash? Say for instance, if I buy a book online, I download the whole book, but how do I ensure that the whole book is downloaded? How do I ensure that for the amount that I have paid, all the pages have been downloaded? What if I have missed something? In that case, what they do is the service provider provides me a hash. Now when I download my whole book after purchasing it, I again compute a hash for the entire book. If both of these hashes match, then I know that I have downloaded, or for whatever I have paid, I have received the entire book. This is a simple analogy that I have given. So this hash is also playing a very vital role in this blockchain. Okay, let's see further. What I would like to do today is, first I would like all the students to realize and understand the basic concept of blockchain first. Having understood the basic concept of how a blockchain works, then we can apply it to any other application. Maybe it is a financial transaction, or maybe it could be in the banks, or maybe real estate, legal services, online voting, stock trading, anything of your choice. I just give you the concepts and would like to further see if you could implement it in any of these applications. That would be a great thing. And most of your projects, you can reorient them and see that you implement this. It's really beautiful to visualize and to have a feeling of developing this. Okay, let's come back to what and how we are going to develop this. First, let's see the issues with the traditional financial transactions. Now, when I say the traditional financial transactions, these days, whenever I want to buy something from a website, in that case, I have to send money. Now, how do I send money? It has to be through the bank. So this third-party involvement is a must. I send money transfer request to the bank, and bank notifies this or notes it in its own ledger. Remember, this ledger is a centralized ledger owned by the bank, which is a third party. And then money will be transferred to the seller, maybe at its convenient time, may not be immediately. It will take its own time. However, apart from taking its own time, it's also going to cost me some amount because my money is going through this third party. Since the third party is providing me a service, it also has its own share there. Thus, we have three things here. One is the involvement of the third party. Second one is it's slower than if I buy it directly or transfer the amount directly. The third one is the cost involved. Why should I pay the bank unnecessarily in between, who is maintaining the centralized data to whatever I purchase each time? That's the major thing. Now let's see how we can overcome these issues. We have to eliminate the middleman and use an open ledger. Using an open ledger can bring transparency in the transactions. Thus, we have to eliminate the centralized system and adopt a distributed system. Apart from this, we also have to reduce the transaction time and the cost involved in it. Thus, we have to maintain the consistency. Now let's see how we are going to understand the concept of blockchain, how exactly it works. Let's consider an example that there are three parties involved in a transaction. A has some amount. Initially, he has say $5 and he would like to send $2 to B. And B would like to transfer say $1 to C. That's a third party. Three parties involved in the transaction. Now during this process, A now tries to send $15 to C. Is that valid? Is the first thing. Now in this distributed and transparent transaction, we all A, B and C can see how much money each one has. What transactions have happened so far? Are these transactions valid? Can all be seen. Now we know that A has $5, so it's sending $2 or transferring $2 to B is a valid transaction, and B in turn transferring $1 to C is also valid because all ABC can see how much money each one owns. Now if A is trying to send $15 to C, then we know that this transaction is not valid. To get into the open ledger, first as A transaction to B and B to C, these two were valid and hence they were entered into the open ledger. But now this $15 is not valid is what we can see because A does not have so much amount of money. Now who will validate this and how is it validated? To validate this transaction, all the transactions from the genesis have to be distributed to all the nodes in the network. And further, the copies of the transactions also have to be shared with all the parties who are involved. So now the new issue is, we say that we have an open ledger and then we share it. All nodes have the same copy. Now having a same copy is obviously redundant in our way, but redundancy really helps us. Now it's not that it is redundant. The major issue here is the synchronization required in order to maintain a consistency. Everyone should have the same ledger. We need to synchronize everyone. Every transaction has to be synchronized with all the members involved. Now how is that done? How do we synchronize? And who is going to synchronize it? Who is going to distribute it? The next answer for this is mining or the miners. So whenever you have any transaction, say earlier we saw that it was centralized. Now to get rid of the centralized issue, Any transaction that's happening with A is also shared with B and C. Immediately it is distributed. Anything happens here is distributed. You can see that all the transactions first have to be validated. Once they are validated, validation is very easy. The reason being, everyone knows how much each one owns the amount. Now, having known that, it's very easy to validate these transactions. After having validated, we have to distribute this. Now, how is this ledger maintained? Ledger is maintained in blocks. Now, each block has got its own data, and it has to have a link with the next block and the previous block. Just like as I said, the doubly linked list, wherein each node in the doubly linked list has an address of the next node and that of the previous node. So also here, in this blockchain, every block is going to have hash of the next block and hash of the previous block, so that it maintains it. Now, whenever there is a new transaction, the new node or the new block has to be joining this chain. When it has to join the chain, then it has to be linked with the hash of the previous block. It has to store in it the hash of the previous block, and the hash of this newly generated block has to be also stored in the previous block. So these two transactions have to happen. Now, first of all, how would we generate or how would we crack this hash? Yes, that's the job of the miner. Now, who are these miners? Miners are few of the nodes who are involved in the transactions. Say if we have 5 people in the transaction, some of them can act. Say some maybe one here and the second one here may act as a miner. So what is the job of this miner? He has to provide the proof of the work. Now how does he provide? He is going to generate, he is going to generate the hash by solving the cryptographic puzzle. So he provides proof of the work. Once he gets the hash of it, then he will link it up with his own blockchain and then further links it up with everyone. He will distribute it. I just want to recap here what is a nonce and what is hashing. As you know, I repeat it, hashing is nothing but it's a function, and it's very crucial in cryptography because you are going to have a valid nonce is discovered by computing the hashes. And this helps to form the consciousness of the blockchain, and the use of hash of the data helps to store in large amounts of data, or any change in this data will change the hash. That's the beauty of this. The hash is specific to the data inside the block. Any information change will also be reflected on the hash and it will not match. That's how if any data is tampered or if anything is edited, then it comes as a new block and as a next node. And what is a nonce here? Nonce is nothing but numbers who is only used once. It is used to make it more difficult to generate a valid hash for a given block. So these miners, they have to compete among themselves. They must find a nonce value when plugged into the hashing algorithm and generates the output. They have to compete among themselves. However, they would be getting some amount for that. And they need high power systems for mining these. Say now here, let's see what is the job of this miner. As I said, Adam wants to send $2 to Ben for buying a t-shirt, not yet a valid transaction. Thus, it's still not entered into the ledger. Now miners will start to validate it. It's an easy task if Adam has that money. Since the ledger is open, everybody can validate that. Yes, Adam has that amount and still he can purchase it. To add this now, once this transaction is validated, it has to be added to the blockchain. Now, to add to this blockchain, the miners are going to compete because there are more than one miners. they have to compete to solve the cryptographic puzzle for the transaction. For that, they have to invest huge computational power to break the key. And the miner who first solves it is going to win the monetary reward and adds the transaction to the ledger. What's a ledger here? It's the blockchain, or in my view, it's a doubly linked list. Then he publishes this valid transaction to all others, who then add it to their own ledger and move on solving other puzzles for the next transaction. This is as simple as it is. Now, how exactly the blockchain works? A different perspective, I can say. When a party requests a transaction, here you can see that one party requests a transaction, then the requested transaction are funneled into the peer-to-peer network and broadcast to each individual computer after having validated, and the miners break the hash, and after that it becomes the part of it. The individual nodes will receive the request and validate the transaction using their own algorithm. Once it's all approved, then the transactions are represented as blocks and added to the public ledger. You can see that this is a public ledger. So the new node or the new block is added. Once the block is added to an existing transactions, then the whole thing is complete. So every transaction will go through it, either in that way, or there's another representation of the same concept. It is in this way. Now, what does each block contain? That's very interesting for us to know. As I said, I repeat, it's nothing but a doubly linked list. You can see that each block is going to have information. Apart from that, it's going to have a nonce based on the time. Then it's going to have a block hash. It's going to have the block hash of the previous one with which it is linked. Now, when I said a new transaction has to be included, so what happens is we need to know what is its hash, and then this has to store the hash of this particular block. That means every node is going to store the hash of the previous block and its own block hash. In this way, it acts something similar to a linked list. There are many applications and are growing. The distributed cloud storage, blockchain data storage will become a massive disruptor shortly. Smart contracts, digital identities, digital voting, decentralized notary could be the applications of future. And also, as visualized, we can see that blockchain will be a service, because blockchain based applications track all the transactions right from the raw materials to the finished goods. This is an answer to the first question that I asked: how do we find whether the product that we buy is legitimate? How do we verify whether a currency is not a counterfeit? How do we verify whether the driving license is original? In Walmart, anyone involved in supply of certain products, they will be able to trace individual items back to the far where they were grown using tamper-proof distributed databases. So the way the data is maintained is what is mattering here. This blockchain even speeds up AI, or I can say AI is also being utilized in blockchain. Another project that we implemented this term was the smart contracts, a civil contract, wherein we have the contractor, and then another is the builder, then we have the suppliers who are going to supply on time. They've agreed the database, so it is shared and it's all automated, so that we have a little bit of AI involved in it as well. Blockchain for IoT, for securing the Internet of Things, is another important thing. So far you can see that up to 2019, this is an information from the Google that I got, 26 million devices are connected machine to machine. That's why we've gone from IPv4 to v6. Every device on this planet has an IP except the human beings. Now, when it comes to healthcare recording system, do we need to secure it? Yes, of course we need to secure. It's not just the documents that are involved, but also the parties who are involved in this. The patients whose information is to be shared. Apart from that, it's also about the insurance company who is involved, so that the insurance company should also get tamper-proof documents, and more so the doctor. The doctor needs to get the original contents without any tamper-proof. The documents should not be tampered. So in order to get all the documents integrated and also to see that it's trustworthy and tamper-proof, we need to have the EHRs safe, that's the electronic health records, have to be stored. Now, what's the situation currently? Even in the first world countries, as I have seen, according to my knowledge, most of the healthcare and the healthcare insurances are using the common cloud. But since at the moment we consider cloud as a centralized form of storage, probably tampering is possible, and there could be single point of failure. The cost of maintenance is also high. Integrity is relatively less among the different organizations of healthcare industry, and hence they are planning to move from the centralized cloud storage to blockchain application. Now, what are the basic requirements for securing the electronic data? We have to store the important medical documents safely without tampering, to ensure documents privacy. That's another important aspect, because privacy is very, very important. Immutability, integrity of the information, and more so the authenticity of documents is stored in the blockchain. Of course, we need to have a web interface for insertion and retrieval of data. Ability to check if a block has been tampered with. And I believe blockchain technology is providing all the above. So what you all students need to do? You all have to critically analyze the concepts of blockchain to store and retrieve the documents safely, along with maintaining the log of all users who are accessing the documents, even if they have edited, when did they edit and what did they edit also has to be kept. This is just a diagram for you to help out to see how the conventional approach is, wherein we have got a remote repository and a centralized approvers, and rest all of them are dumping the contents. Now, what do we need to have different, or what are the different entities that are involved in the healthcare system? You are going to have heterogeneous medical data, I would say unstructured and structured data. It's not just the text, it could be pictures or whatever. It's going to be unstructured and a big data involved. Then it's going to be the pharmacy company as another party. R&D also would like to involve. The healthcare payers, the insurances, all are going to be involved, along with the patients, the data of the patients, and also about the hospital. Now in this diagram you can see that we have done till up to here. That's the data management layer. Up to the data management layer, it's existing, be it a HIPAA or any other healthcare provider, A, B, all of them are here on the cloud, where they are going to store all the electronic health records. The data management layer is also involved here, but now we would like to have the blockchain cloud. That's very important, and if you can implement it, I mean, if you can develop a prototype, then later you will have very good opportunity in any industry because the future is cybersecurity and AI, as I know with my limited knowledge. Hence, we all need to see how blockchain works. I know it's not that easy, or it doesn't mean that it doesn't come up with any limitations. Of course, there are many limitations in implementation, the computing power, the time required, and so on and so forth. But however, it's good for you all to explore. So here, as I shown the diagram, pre-blockchain was a centralized. With blockchain, you are now making it peer-to-peer in this way. Just the Netflix way, I can say. However, there's no security required there, but we need to add in more security here. A distributed ledger with decentralized verification and computation, so that the authority is distributed, there's no single point of failure, and it's also trustworthy. As I said, blockchain in a nutshell, it could reinvent the way patients' electronic health records are shared and stored by providing very safe mechanisms for the information exchange of medical data in the healthcare industry. So this is done by securing it over a centralized peer-to-peer network. That's very important for us because it's less prone to failure, as well as it provides a tamper-proof. I have a video for you all. In case we have time, I would like to play, or I would give you references wherein you can play it for yourself. There are many more available. You can
91 by a group of researchers.
This is a very interesting one for the beginners, I could say. You can be using it, or we can go further so that you can further listen to it later whenever you have time.
Hello, ma'am.
Should I play that, sir?
Yes, ma'am.
Okay.
91 by a group of researchers, and was originally intended to timestamp digital documents so that it's not possible to backdate them or to tamper with them, almost like a notary. However, it went by mostly unused until it was adapted by Satoshi Nakamoto in 2009 to create the digital cryptocurrency Bitcoin. Now, a blockchain is a distributed ledger that is completely open to anyone. They have an interesting property. Once some data has been recorded inside a blockchain, it becomes very difficult to change it. So how does that work? Well, let's take a closer look at a block. Each block contains some data, the hash of the block, and the hash of the previous block. The data that is stored inside the block depends on the type of blockchain. The Bitcoin blockchain, for example, stores the details about a transaction in here, such as the sender, receiver, and the amount of coins. A block also has a hash. You can compare a hash to a fingerprint. It identifies a block and all of its contents, and it's always unique, just as a fingerprint. Once a block is created, its hash is being calculated. Changing something inside the block will cause the hash to change. So in other words, hashes are very useful when you want to detect changes to blocks. If the fingerprint of a block changes, it no longer is the same block. The third element inside each block is the hash of the previous block. And this effectively creates a chain of blocks, and it's this technique that makes a blockchain so secure. Let's take an example. Here we have a chain of 3 blocks. As you can see, each block has a hash and the hash of the previous block. So block number 3 points to block number 2, and number 2 points to number 1. Now the first block is a bit special. It cannot point to previous blocks because, well, it's the first one. We call this block the genesis block. Now let's say that you tamper with the second block. This causes the hash of the block to change as well. In turn, that will make block 3 and all following blocks invalid because they no longer store a valid hash of the previous block. So changing a single block will make all following blocks invalid. But using hashes is not enough to prevent tampering. Computers these days are very fast and can calculate hundreds of thousands of hashes per second. can effectively tamper with a block and recalculate all the hashes of other blocks to make your blockchain valid again. So to mitigate this, blockchains have something that is called proof of work. It's a mechanism that slows down the creation of new blocks. In Bitcoin's case, it takes about 10 minutes to calculate the required proof of work and add a new block to the chain. This mechanism makes it very hard to tamper with the blocks, because if you tamper with one block, you'll need to recalculate the proof of work for all the following blocks. So the security of a blockchain comes from its creative use of hashing and the proof of work mechanism. But there is one more way that blockchains secure themselves, and that is by being distributed. Instead of using a central entity to manage the chain, blockchains use a peer-to-peer network and everyone is allowed to join. When someone joins this network, he gets a full copy of the blockchain. The node can use this to verify that everything is still in order. Now, let's see what happens when someone creates a new block. That block is sent to everyone on the network. Each node then verifies the block to make sure that it hasn't been tampered with. And if everything checks out, each node adds this block to their own blockchain. All the nodes in this network create a consensus. They agree about what blocks are valid and which aren't. Blocks that are tampered with will be rejected by other nodes in the network. So to successfully tamper with a blockchain, you'll need to tamper with all the blocks on the chain, redo the proof of work for each block, and take control of more than 50% of the peer-to-peer network. Only then will your tampered block become accepted by everyone else. So this is almost impossible to do. Blockchains are also constantly evolving. One of the most recent developments is the creation of smart contracts. These contracts are simple programs that are stored on the blockchain and can be used to automatically exchange coins based on certain conditions. More on smart contracts in a later video. The creation of blockchain technology piqued a lot of people's interest. Soon others realized that this technology could be used for other things, like storing medical records, creating a digital notary, or even collecting taxes. So now you know what a blockchain is, how it works on a basic level, and what problems it solves. Want to learn how you can implement a simple blockchain in JavaScript? Then check out this video.
Now, once we have seen that, a few questions for all the students over here. What features of blockchain will provide better security than the existing technology, something like RDBMS? Are we going to have a public or a private blockchain for a given application? How do we introduce access privileges within the blockchain? Does the blockchain provide minimum latency in accessing the records? Or do we have a very good user-friendly access, maybe like voice recognition system within the blockchain-based repository to provide security and convenience altogether? Are some of the questions which you all need to ponder upon, think about, and maybe learn more than what we have discussed here. Of course, there are many advantages. It reduces the cost of validation along with the cost of diagnosis in medical, because you are going to provide the entire history. It supports end-to-end supply chain, and of course the research. There are many platforms on which the blockchain can be developed. Ethereum is one of it, but it requires payment, and Solidity is the structured language that is used for developing the distributed application on the Ethereum platform. It could be some other platform like Hyperledger Sawtooth, which is backed up by Intel and it's founded by Linux. Or it could be IBM blockchain, multi-chain, Hydra chain, Ripple. I have given a link over here wherein it will compare the different platforms for you to implement. Since I have not dealt with any of the implementation details here, I would leave it to all the computer science students who are very good in coding. You need to understand the concept and build your own distributed application. Maybe you can develop your own voting application, use it in your own college to select your own representative, or maybe you can develop it to store the question papers in a secured manner. That's the best application that they're trying to do it in India for storing the question paper of maybe year 10 or 12 in CBSE. They're trying to use a blockchain technology. Once they store it there, and automatically using the smart contract, the papers would be delivered. Anything is tampered will be soon notified. There are challenges. As I said, it doesn't come up, everything is not green. It comes up with certain challenges and many vulnerabilities. It's a new technology. However, it's still in development, not reached the saturation. And if you want to any update, software developed, it's very complex process because it has to be updated on all the participants and so on. These are some of the challenges. There are many more research challenges here. The vulnerabilities are also there because each block contains a hash which is generated by the algorithm, and if that algorithm is hacked or if there is a bug in the algorithm, then we are giving space for all of the attackers. With this I complete my presentation on blockchain. However, for the students, I would like to say that if you are going to carry out a project, it has to be done in a very effective way. Any project, please don't take it lightly. I would say it's not just a lab exercise that you execute and get the results. I know it's very hard, all of you are in a rush, but give some time and importance to the project and the supervisor there so that you can do real-time projects. Especially the computer science students, please go out into the market, meet the clients, find out the requirements. Once you collect the requirements, do a good literature review. Find out what others are, how others are solving this around the globe for this client requirement, how others are doing it. Then come up with the research questions. What's the problem domain? Try to learn that. Combine the requirements that you have collected and the literature review to come up with your objectives for the project. Then if you are doing project in a group, then come up with a holistic view first. Then I would suggest each member involved to come up with their own design. Then you can compare and contrast the designs. Select any two designs for implementation so that you can validate one with the other. The results that you get have to be really analyzed and compared, and your project work doesn't complete over here until unless you publish a paper. Could be on a simple IEEE conference or any good peer-reviewed journal. For bachelors, it is a must. I would request Satish sir to see that they publish the work. I think they have been doing now, but still it's good that you all do it. I thank now all the organizers, more so with Satish sir, for taking in so much of effort in arranging all of this event. Thank you. And the students, if you have any queries or any other things, please keep them posted with your HOD. I will pick up and then try to answer whenever time permits. And thank the KLE organization and all the members involved. Thanks, Anami sir, for your patient hearing.
Thank you very much, ma'am. It was a very wonderful session. Now I have a few of the questions that were being sent via the chat box in this Google Meet as well as YouTube Live. Shall I take up those?
Sir, could you please send them so that I can answer asynchronously a bit later? I can respond.
Okay, ma'am. No issues, ma'am. No issues.
Yeah, sure.
Thank you very much, ma'am. So just for 2 minutes.
I'm not sure if I was clear enough, but I made my best effort.
No, ma'am. It was absolutely a fantastic session that we all had. Everyone was motivated.
Sidna madam idre
Yes, I believe it would. And let's see how we can do it and works. It would be good.
I think Dr. Anami sir is on the line.
Yes,
Yeah.
sir. Hello.
Madam, it was a very good presentation. I am hearing you after a long time and seeing you also after a long time.
Yes, sir. I was so happy to see all of you, sir. I
I'm
can
really
see.
happy.
Yes, sir. I can see Devi, Uttam.
We'll do some,
Yes,
we'll
sir.
do some collaborative work.
Yeah, definitely, sir. I'll be more than happy. Manisha is also there.
Yeah. Thank you. Thank you, ma'am. Thank you.
Thanks a lot.
Shanta is also with me.
Yeah, I can see her, sir.
Thank you, ma'am, for your happy
Yeah.
appreciation.
Yeah.
Okay, thank you. Take care.
Yeah. Thank you, sir. Bye. Bye.
Ma'am, just for 2 minutes, we'll have the vote of thanks, then we'll wind up, ma'am.
Yeah, sure. Yeah.
Good evening all. I, Professor Bahubali Ekwate, Department of Computer Science and Engineering, KLECET Chikodi, feel privileged to propose vote of thanks. As all good things come to an end, so is the today's session of webinar. On behalf of KLE College of Engineering and Technology Chikodi, I take this opportunity to thank to those who have directly and indirectly contributed to this webinar series on recent trends in computer science and technology organized by our Department of Computer Science and Engineering. At the outset, I thank our speaker and resource person, Dr. Nandini Sidnal, HOD for Masters Program at Melbourne Institute of Technology, Sydney Campus, Australia. We are really enlightened with your knowledge and presence, madam. I would like to thank our beloved principal, Dr. Prasad Rampure, for his enthusiastic support and motivation. A special thanks to our organizing committee, teaching and non-teaching staff for their unflinching support and coordination. Our heartfelt thanks to our all participants for their active participation. With these warm words and a kind message, we move to the end of the today's session of webinar series. This is also the last session of this webinar series. Thank you one and all.
Thank you very much.
Yes, sir. Please convey my best wishes to Rampura, sir. Thanks.
Yes, ma'am.
Sir. Thank you.
Okay, ma'am. Thank you very much, ma'am.
Yes, thank you, sir.
Dear participants, the attendance of session number 4 will be shared with you now. The attendance link of session 4 will be shared to all the participants. Please give your attendance. After some time, the feedback of session 4 will be shared to you, and all the certificates will be delivered to all the participants on Monday.
Hello.
Yes,
Hello,
ma'am.
sir.
Ma'am.
Sir, actually, session 3's feedback I missed it, sir. Due to poor connection, I rejoined, so chat was closed. So I'm not able to get it. And again, I'm asking for that. But I checked in mail also, sir, because session 3 was sent in mail. And session 3, I keep on asking. I didn't get it because from session 1 I am attending work.
You given 3 sessions feedback, no, ma'am?
Either it's
You given 3 sessions feedback or not?
yeah, first session attendance I gave, so second session feedback it was in mail I gave it. Third session only I missed it. And fourth session now I am attending.
Now you can give, ma'am. Now we are sharing attendance sheet.
What's
Already
that?
shared. we have already said for session attendance sheet, you fill it.
Okay, sir. Here in this link, sir, in this link we have all the 4 sessions.
Yeah, only one.
Sir? Hello? Okay. Hello?
End moderate. Microphone moderate.